Hi, so how this lesson is going to go today is you're going to be working through the Science 10 Lesson 5 practice, and hopefully by now you have done questions 1 through 4. So what we're going to be doing is we're going to be going through questions 1 through 4, and then we're going to do 5 kind of all together. Then you're going to have some time in order to do uh, 6 through 13, and then we're going to kind of take those up together. So make sure that you're pausing the video when you should, just so that you kind of get the most out of this. All right. So question 1, a dog runs 50 meters west for 5 seconds. Well, calculate the average velocity. So first of all, I'm just going to write down kind of the values that I know in the question. And so I've got 50 meters west in 5.0 seconds. Those are the two values that I am given. So what I'm going to do is I'm going to think to myself, okay, well, what variables go along with these? Meters and direction, well, that's displacement. Seconds is a unit of time. There we go. The question is asking me, what is the average velocity? That's what I'm trying to figure out. Well, here is my dog, and he is running west. Beautiful picture there for everybody. Now, I'm going to look at my data booklet, and I'm going to find the formula. Velocity is equal to displacement over time. So I need to sub in my values now at 50 meters west divided by 5.0 seconds. And not like I need the calculator, but just in case, here we go. I've got 10 meters, sorry, here, 10 meters per second west. All right, two significant figures in my question. I've got two significant figures and two significant figures, so I'm in the proper amount of significant figures, and there is my answer. All right, next question. A truck travels 25 meters north for 2.5 hours. What is the displacement of the truck? Well, I've got, again, my values here, 25 meters per second, and that is in the north direction. I've got 2.5 hours. So 2 hours is a unit of time. Meters per second is a unit of velocity, especially meters per second north. And the question asked me, what is the displacement of the truck? Beautiful. Now, truck traveling, it is traveling north. Beautiful. Question is asking me for that because that's what I don't know. I don't know how far he went. So velocity is equal to displacement over time. I need to isolate displacement here. So in order to do so, I'm going to multiply both sides by t so that I can get rid of the t in the denominator. So displacement is equal to time times the velocity here. So now this is the moment where my feeler should go up, and I should see something that shows here with hours and seconds. These two units of time don't match, okay? So because of that, I need to convert one into the other form of time. So what I'm going to do actually is I'm going to turn my hours into seconds, because to me that makes the most sense. So in order to do so, I'm going to multiply by 3,600, because that's how many seconds per hour. The hours cancel out. That tells me how many seconds that I have. So here we go, 2.5 multiplied by 3,600. And I get 9,000 seconds. So I'm going to now take that 9,000 seconds, and I'm going to multiply it by 25 meters per second. 25 meters per second, and this is north. Okay, so times by 25 meters per second, and I get quite a large number here at 225,000 meters. Well, that's a whole lot more significant digits than the two that I'm given in the question. So it turns into 2.3 times 10 to the 1, 2, 3, 4, 5. Okay, to the 5 meters. Now I could also put this into kilometers by taking this value and dividing it by 1,000, because there's 1,000 meters per kilometer, and I would get 225, sorry here, 225 kilometers, which again to two significant digits turns into 2.3 times 10 to the 2 kilometers. Either one of these answers are correct for this particular question. Oh, sorry, I lied. Both have to say north. Okay, so don't forget, the question is asking you for displacement, so I need to include direction. All right. Calculate the average velocity in both meters per second and kilometers per hour for a plane traveling 500 kilometers west in 102 minutes. Well, here's my plane. He is traveling west, okay, over a distance of 500 kilometers. Now, it takes him some time to do so, but I've got this value of 500 kilometers west. That is a displacement because I've got magnitude and direction. And I've got a time here of 102 minutes. Now, my feelers should go up because we should say, I never use minutes. So I have the choice whether to turn this into seconds or hours. Now, because I already have kilometers, I'm probably going to change this into so many hours. And in order to go from minutes to hours, I need to think to myself how many minutes are in an hour. So in this case, I need to divide by the 60 minutes per hour. That cancels out my minutes. I'm left with hours. So I'm going to take here 102 and divide it by 60, and I get a value of 1.7 hours. So now I'm looking at what the question is asking me for, which it's asking me for its velocity in kilometers per hour. Perfect, because I have both of those. And it's asking me for it in meters per second, which I can calculate after. So velocity is equal to displacement over time. I don't have to rearrange this because it's already solving for the velocity, which the question is asking me for. So I've got 500 kilometers west divided by 1.7 hours. So 500 divided by 1.7, I get 294, sorry here, 294 kilometers per hour. Three significant figures, 3 and 3, perfect. So my answer is in the correct number of significant digits, and I would have to say also this is west. So that's the number of kilometers per hour. Now, in order to get from kilometers per hour to meters per second, what we need to do here is divide it by 3.6. Remember, our scale factor is 3.6, and in order to figure out whether I multiply or divide, one of the things that I have to think to myself is that 100 kilometers per hour is roughly 28 meters per second. So in this case, I should be able to figure that that is divide. So 294. Now, note that I don't retype in 294. I want to keep all those significant figures in there. Okay, so I'm going to just take that answer, divide it by 3.6, and I get 82, here we go, or 81 point, I guess 3 significant figures, right? 81.7 meters per second, still in the same direction of west. There we go. All right, so here we go. Last question here before we learn something new. How long does it take a skier to travel 5 kilometers south at 3 meters per second? Well, I've got my skier here. Look at him ski. Beautiful. Okay, he travels 5.0 kilometers, and he is traveling at a velocity of 3.0 meters per second. We're going to assume that that is south since he is traveling, or since he covered the 5 kilometers south. So I've got 5.0 kilometers south. That is a displacement. It is telling me also 3.0 meters per second, and we've assumed south. That is his velocity. Now, question is asking for how long. That is time. So in my data booklet, velocity equals displacement over time. I need to isolate time. It can't be in the denominator then. So I need to multiply both sides by t. So I get d equals t times v. Now I need to get rid of the velocity here, so I'm isolating time, so I'm going to divide both sides by v in order to cancel out v. So now I know time is equal to displacement over velocity. Okay, I lost my arrows there, but they're back. Okay, so sorry, let's clear that up. Velocity. Okay, now when I go to do my subbing in, my feelers should go up and they should say, hey, wait a minute, I got kilometers here and only meters here. So I need to convert one of those. The easiest one is going to be convert the distance. So 5 kilometers, well, I'm going to multiply that by 1,000 because there's 1,000 meters per kilometer. That cancels out my kilometers. I'm left with meters. So 5 times 1,000, not like we really needed to do that, but we get 5,000 meters south. Okay, so now I'm going to sub in my values here. So 5, well, let's draw a better one here. 5,000 meters south divided by 3.0 meters per second south. Okay, south and meters cancel. I'm left only with seconds. So 5,000 divided by 3 gives me 1,666.6 repeating seconds. Okay, because I'm only left with seconds now. So it's 1,666.6 repeating seconds. Two significant digits is what I need to round to. Because I'm given two significant figures in the question. So this is going to turn into 1.7 times 10 to the 3 seconds. If I wanted to have that value in hours, I would divide this by 3,600, okay, and I would get 0.46 hours. Either one of those would have been acceptable. All right, so now it's time to learn something new. Now you may have done a few of these and then you probably ran into something where you're like, hold on, wait a second. And now it is time for us to take this up kind of as a class. So first of all, I'm going to go and draw out kind of my directions here with north, south, east, and west here, just to make this a little simpler on myself. So using a vector diagram, now we haven't talked much about vector diagrams necessarily. Okay, we know a vector, it has magnitude and direction. We can represent that with an arrow. And I've been drawing them, but we haven't been necessarily using that term of a vector diagram. So we're going to just do some of these examples, or these 4 examples here, in order to help us understand what's going on. So A says a car travels 5.5 kilometers east, so 5.5 kilometers in the eastern direction, and then another 12 kilometers east. Now note that the 12-kilometer arrow is much longer than the 5.5-kilometer arrow. It should be almost double that, or over double that, because that's the magnitude portion. So now my resultant, okay, which the question is asking us for the resultant, is from where I start to where I finished, okay? Now, we want to know the amount that this is, and in this case, I'd be taking 5.5 and adding it to 12 kilometers, so I would get 17.5 kilometers, and of course this is east. Okay, so nice and easy. We've done a lot of that already. So now what we're going to do is we're going to look at B. B says a student walks 100 meters north. And then turns around and goes 40 meters south. So we're going to draw our resultant. So from where I started to where I finished, okay? We're going to note that that is in the northern direction. Okay, and then now in order to calculate this, I'm going to take 100 and add to it negative 40 because we're going to say that south is in the negative direction. Oh, delete here. And I'm going to get 60 positive. So that's great because we've said that north is my positive value. So 60 meters in the positive direction. Beautiful. So just to clarify here, we've said that south is negative. Okay, so I might draw something that looks like this and says that north is positive where south is going to be negative, just to keep it straight for me. Okay, so here we go. Now we're getting into something a little bit more complicated. And I'm going to zoom all the way up here just so that I have some blank room. And you have this in front of you, so it should be fine. Here we go. So never eat soggy wieners. Perfect. We've got that in there, so we have our directions. So a plane flies 300 kilometers west. And then 200 kilometers south. Now, these are no longer along a straight line. Okay, now we're working in a three-dimensional surface, or I shouldn't say three, a two-dimensional surface, which means now we have to kind of be more clear in what we're saying. Okay, so 300 kilometers west, 200 kilometers south. My resultant is from where I started to where I finished. Now, if you look at this, you're hopefully saying to yourself, hey, that looks like a triangle. Not just any triangle, but a right angle triangle. And hopefully you know a thing or two from math class about right angle triangles. So in this particular question here, we are going to figure out the resultant. Okay, and we're going to do that by using Pythagorean theorem. And hopefully you remember Pythagorean's theorem of a squared plus b squared equals c squared. C, remember, is my hypotenuse. Okay, that is equal to c. So it's very important that we keep that straight. So a squared, we're just going to say that's 200 kilometers squared plus b squared, 300 kilometers squared. And I'm going to take the square root of that, and that will tell me what my resultant is. Now, I'm old school. I like doing this in 2 steps. You could do it in 1, but I like doing it in 2. So 200 squared plus 300 squared is going to give me a value of 130,000. Now I'm going to take a second square root of my second answer, and I get 360.5, so 361 kilometers. That makes sense, okay? It is more kilometers than either of my sides, which makes sense for a hypotenuse if we know a thing or two about math. Now, in order to figure out what direction, because we can't just say you're 361 kilometers away, we need to put direction into this, right? This is very important. So what I want to do is I want to draw my coordinates system where I started. So north, east, south, west. And we're going to notice that this line, or my resultant, is some is what we call south of west. Okay, so we're talking about now south, south, of west. Okay? Now, what we need to do is we need to find out how many degrees south of west we're talking about. And hopefully, again, you know a little bit about math, okay? And you know what's SOHCAHTOA. Now, in this, I didn't have the hypotenuse to begin with, so I would never use my hypotenuse in this one of these calculations. So we're going to look at the tan. So tan theta is equal to opposite. In this case, the opposite is going to be 200 kilometers all over the adjacent, which would be 300 kilometers. So 200 divided by 300 is going to give me 0.6 repeating, and I'm going to do the second tan function of my second answer to give me 33.69 or 33.7 degrees. So 33.7 degrees. Note if you did not get that your calculator may be in radian mode, so you need to go to mode, okay? And then down here you need to select degree by saying enter, okay? And then you can quit out of that, okay? So if you didn't get 33.7, you're probably in the wrong mode, so you need to make sure that you're in the right one. So now to report my answer correctly, I would say that I am 300, or my resultant is, I'll do this in green, 361 kilometers at 33.7 degrees south of west. Okay, so good. Now we're going to do D. D is significantly more complex, so we need to be paying attention as we move into D. So I'm just going to clear this away. Now, you have this in front of you, so just follow along. I'm going to do my coordinates over here, north, east, south, west. Beautiful. Okay. Here we go. A car drives 5 kilometers south, and then 2 kilometers east, and then 3 kilometers north, and then 4 kilometers east again. Now, my resultant is from where I started to where I finished. And you're probably saying to yourself, oh my gosh, that is not a triangle at all. But really, there is a triangle. And the triangle is here. And it should be a right angle one. So what we're going to be doing now is we're going to figure out how big this triangle is. And what I'm going to do, or how I'm going to do that, is I'm going to assign direction to each of these. Now, in this case, we're going to say, for the sake of argument, that south is positive. I know, confusing, but it really doesn't matter whether I say which one is positive or which one is negative. It really doesn't matter. It's just a way of assigning direction. And we're going to say that east is positive, okay, and west is negative. So both of these are positive here. So in this case, I would do 5 plus a negative 3 in order to get this value here, and I would get 2. Okay, so I traveled a total in that case of only 2 kilometers south. Then I'm going to do my easterly direction, which is going to be 2 and 4, okay, which is 6 kilometers east. Resultant here, okay, is still in this direction here. Now, again, I'm going to put my coordinate system here in east, south. So we are going to be talking now the easiest way to do this, because my line goes south first, is we're going to talk of so many degrees east of south. Okay? Because that's the area that I have in there. That's what theta is. It's so many degrees east of the southern line. All right, so what we need to do now is we need to figure out this line here, my hypotenuse. Okay, we're going to do Pythagorean theorem again. So, oh, sorry. Here we go. A squared plus b squared equals c squared. So we're going to take the square root of 2 squared plus 6 squared. Okay, now if I wanted to do it as one step in my calculator, I would do my square root of 2 squared plus 6 squared. Now I know it's not that hard, but I just like being a bum and I don't like putting it all in my calculator. But here we go. So quite easy, a total of 6.3 kilometers. Now we need to figure out how east of south is it? Well, we're going to do SOHCAHTOA again. Now, because we weren't given hypotenuse, we're still doing tan theta is opposite over adjacent. So in this case, right, opposite is going to be 6 kilometers over adjacent is going to be the 2 kilometers. All right, so 6 divided by 2 gives me 3. And we're going to do the second tan of that answer. And that gives me 71.5 degrees or 72 degrees, and this would be east of south. So as my total answer, oh, it went up a little too far there, my final answer is 6.3 kilometers at 72 degrees east of south. All right. Now, here is the moment in which you are going to stop the video. Okay? So, I want you to stop the video here, and I want you to do questions 6 through 13. Okay? 6 through 13, and then what we're going to do is, in the next part of this video, we are going to be doing questions 6 through 13. But I'd like you to try them out yourself. So make sure that you try them out yourself first, and then once you've done all that you feel like you can do for these questions, then you should look at the next half of this video. Okay, so hopefully you've taken the time in order to do questions 6 through 13. And here's what we are going to do now, is we are going to look at these, the answers to these questions, make sure that we got them correct so we have a solid understanding. So 6 says a student leaves a classroom in house A and walks 20 meters down the hall in the southern direction when she meets a friend, and they walk 14 meters back down the hall to the north. Calculate their displacement. So I need my coordinates here. Okay, so it says here that she starts in a classroom and walks 20 meters down the hall south. She meets her friend and they walk 14 meters back down the hall north. So my resultant is there. Now I know I drew that as kind of like a crooked arrow, but it should be a straight one. So this would be south. Okay, we can see that. Now to figure out how much it is, what I'm going to do is I'm going to just say that south is positive, north is negative. So this is positive and this is negative. So 20 plus negative 14 gives me 6, positive 6, which is why I know that it is south. So that works. So my answer here is going to be 6.0 meters south. Why 6.0? Because two significant figures. All right, here we go. 7. A truck that drives 59.0 kilometers east and then 97 kilometers west. We need to calculate the distance traveled and then the displacement traveled. So for A, okay, let's put in here my coordinates, east, west. We're going to say for this east is negative, west is positive. Okay, so he drives, hold on, there we go. All right, so he's going to drive 59 kilometers east and then back 97 kilometers west. We said east is negative, west is positive. My resultant here is from where I started to where I finished. Okay, and we note that that is going to be in the westward direction. Now, A is asking me straight up for distance, not for displacement. So here's where it does not matter what direction. So in this case, we have 59 plus 97 kilometers because, again, this is what you care about, right? This is everywhere you have been, okay, regardless of where you started versus where you ended. So we've got 59 plus 97, and I've got 156 kilometers here. B is asking me for the displacement, so now it cares about direction. So now we know that we're going to be going west, okay? And now this is where I need to make sure that I include positive and negative to indicate my values. So 97 plus negative 59. And I get a total of 38 kilometers. And because it's positive, we can confirm still that this would be west. Okay, so remember, distance is everywhere that you've been. Displacement just cares about where you started versus where you finished. All right, now we're doing question number 8. A cat runs 125 meters west and then another 15 meters south. So now this is where, again, we're going to have to care and use a little bit of trig here. So a cat runs 125 meters west and then another 15 meters south. Okay, my resultant is from where the cat started to where the cat ended. Okay, so this is again C, which is my hypotenuse in my right angle triangle. So A squared plus B squared equals C squared. So the square root of 15 squared plus 125 squared is going to give me, so 15 squared plus 125 squared gives me, now I'm going to take my second square root of that answer, give me 125.9 meters. Got two significant digits, so 1.3 times 10 to the 2 meters for this particular question. Now I need to figure out in what direction. So coordinates go at where I started, north, east, south, west. So note here that my angle that I'm trying to calculate here is going to be so much south of west. Okay, south of west. So we're gonna do a little SOHCAHTOA. Again, I wasn't given the hypotenuse, so I'm doing tan theta. equals opposite. In this case, opposite is 15 meters divided by the adjacent, which is 125 meters. So 15 divided by 125 gives me 0.12. Now I'm going to do second 10 of that second answer, and I get 6.88 degrees. So my entire answer is going to be 1.3 times 10 to the 2 meters at 6.8 degrees south of west. Okay. So, it's getting there. Lots of practice. Okay. So we are now going to calculate number 9. A plane flies 500 kilometers west, 600 kilometers north, and then 200 kilometers east. So, put in my coordinates. 500 kilometers west, 600 kilometers, and then 200 kilometers. My resultant is from where I started to where I ended. So now I need to figure out what that triangle actually is. And I do that by saying that, you know what, that 200 kilometers east is going to be negative. So in order to figure that out, we are going to have 500, right? This value minus that value, because really we want to draw the line here. Okay, so 500 minus 200 means that we are going to be doing 300 kilometers west and the 600 kilometers south. Okay, oh, sorry, that should have been north. Darn it. Let's draw this again. I'm just going to switch this around here and do it this way. Okay, so just 600 kilometers north now, and this is going to be the 300 kilometers west still. Okay, so let's just get rid of this so we're not confused. Sorry about that. So my resultant here, again, so we went 300 kilometers west, and we went 600 kilometers north. So my resultant here looks like that. Okay, remember I put my coordinates where I started at. So in this case, west, north, this is going to be so much north of west. Okay, now, because that's where the degrees is going to go in here. Now I need to figure out what my hypotenuse is. So a squared plus b squared equals c squared. So the square root of 600 squared plus 300 squared is going to equal c, which is my hypotenuse. So I'm going to take the square root of 600 squared plus 300 squared. That is going to give me a value of 671 kilometers. Now we need to figure out the degrees. So again, we're doing a little SOHCAHTOA. I still haven't gotten the hypotenuse, so this is still going to be tan theta equals opposite over adjacent, or a little TOA. So tan theta equals my opposite, 600 kilometers over adjacent, 300 kilometers. 600 divided by 300 gives me 2, and second 10 of that answer gives me 63.4, or just 63 degrees. And again, we said this would be north of west. Okay, so my total answer for this particular question is equal to 670, oh, sorry, here, 671 kilometers at 63 degrees north of west. All right. Now, what we're going to do is, this question should be a little easier here because we're only dealing with east and west. So Jennifer throws a softball. So we're going to do east, west, positive in the east, negative in the west. So Jennifer throws a softball 7.2 meters east, and then throws it another 9.5 meters east, and then it goes back 9.1, oh, sorry, 8.2 meters, and then 9.1 meters, 8.2, and then back 9.1 meters. So we need to figure this out. We said in the westerly direction was going to be negative, in the easterly would be positive. So before that, though, the question A is asking me just for the distance traveled. So that's going to be D1 plus D2 plus D3 plus D4 in this particular instance, regardless of direction. So 7.2 meters plus 9.5 meters plus 8.2 meters plus 9.1 meters. So 7.2 plus 9.5 plus 8.2 plus 9.1 gives me a total of 34 meters. Okay. Now, B asks me for the displacement. So now the direction counts. So we're going to do positive 7.2 meters plus a positive 9.5 meters plus a negative 8.2 meters plus another negative 9.1 meters. So here I've got 7.2 plus 9.5 plus negative 8.2 plus negative 9.1. And I get a value of negative 0.6. Well, we said that negative equals west, so this becomes 0.6 meters west. Okay. Now, C asks for the speed. The question gave me t in the, t was given to me in the question at 6.0 seconds. Okay, I've got my distance of 34 meters, so V equals D over T. So 34 meters divided by 6.0 seconds, 34 divided by 6. Oh, that's wrong. Here we go. Sorry. 34 divided by 6. 5.6. So the speed is equal to 5.6 meters per second. Now D is asking me for the velocity, so now I care about direction. So I'm going to be using displacement of 0.6 meters west and a time still of 6.0 seconds. Velocity is equal to d over or displacement over time, sorry. So 0.6 meters west, all divided by 6.0 seconds, and I get, sorry, 0.6 divided by 6, I get 0.1 meters per second west. All right, so a lot going on there, but once we know the difference between speed and velocity and distance and displacement, it's quite easy. All right, so question number 11. Never eat soggy wieners. There we go. North, south, east, west. A car drives 450 kilometers south of Edmonton and then drives west 25 kilometers in 5.5 hours. Calculate the speed, velocity. Well, first is asking me not for velocity, but it is asking me just for speed. Distance is equal to the first distance plus the second distance regardless of direction. So this becomes 450 kilometers plus 25 kilometers. And I've got a time there of 5.50 hours. I'm going to report my speed, which is distance over time in kilometers per hour. So 50 plus 25 gives me 475 kilometers. So this is equal to 475 kilometers, all divided by 5.5 hours. So divided by 5.5, and I get an answer of a speed of 86 point, only 86, two significant digits. Okay, so 86 kilometers per hour. Now the next is velocity. So B is asking me about the velocity. Now I need to care about displacement, and my time is still 5.50 hours. Now we need to care here, north, south, east, west. It says that the car drives, okay, 450 kilometers south and then drives west 25 kilometers. So right angle, there's my resultant. That's my C. Okay. And we notice that if we were to put the little coordinates here, so it would be so many degrees west of south. Okay. Theta. Um, Now, in order to figure out how far, again, a squared plus b squared equals c squared. So this is 25 squared plus 450 squared. If I take the square root of that, I'm going to be given c. So the square root of 25 squared plus 450 squared gives me an answer of 450.69 or 451 kilometers. All right. Now, if I was to figure out my velocity, velocity is displacement over time. So now we're going to do 451 kilometers divided by the 5.50 hours. I'm going to keep all of the significant figures in here because I want to be as accurate as possible and only round to the end. So this becomes now 82 kilometers per hour. Now I need to state direction. So again, we're going to do the tan theta equals opposite. So in this case, 25 over adjacent, which is 450. So 25 divided by 450 gives me that decimal. I'm going to do my second tan of that answer, and I get 3.2 degrees. And we said that that is west of south. this makes sense, right? In comparison, they traveled very little distance west. So the answer becomes, for my final answer here, 82 kilometers per hour at 3.2 degrees west of south. Beautiful. All right, now we are going to do question number 12. A canoe moving at 10 meters per second in a river has a velocity of 3.5 meters per second. The river is 100 meters wide. Calculate the resultant velocity when the canoe is moving downstream, resultant velocity when the canoe is moving upstream, and then when they're moving across each other. So let's see here. A. If the canoe is moving downstream, that means that the river and the canoe are traveling in the same direction. So this becomes the canoe at 10 meters per second plus, we're going in the same direction, the 3.5 meters per second. So that would equal 13.5 meters per second downstream, whichever way downstream happens to be for this river. Now, sorry here, B talks about when the canoe is moving upstream. So now they're moving in opposite directions. So the canoe again said 10 meters per second, but now the river is fighting it at 3.5 meters per second. So now my resultant is this section here. So we're going to do 10 plus negative 3.5, and I get 6.5 meters per second in the direction that the canoe is traveling. Now C, we need to whip out our coordinates here. Okay, because in this case now, the canoe is moving north and the river is moving west. So, I don't like this question because of the way that it is worded. We are going to say the the river is moving west. Okay, the river is moving west at 3.5 meters per second. Now it says that the canoe is traveling north. We're going to assume that they're actually paddling north. Now I know that that sounds funny and you're thinking, what the heck, right? But we're going to assume that they're actually just paddling straight north. Now the reason for that is because if this was to happen, right, the canoe would drift, it would drift west. Okay, so we're going to assume that they're not compensating for the river at all. Okay, so now we're going to do a squared plus b squared equals c squared. So 10 squared plus 3.5 squared equals, as a square root, equals c. So the square root of 10 squared plus 3.5 squared, I get 10.59. So 10.59. So we'll do two significant figures, so 11 meters per second. Now we know that the river, or obviously this isn't quite accurate, right? So we're going to start we're going to put our coordinates there where we started. And we're going to see that this is going to be theta degrees north of west. Okay, so what we're going to do now is, so tan theta equals opposite over adjacent, which is 3.5. 10 divided by 3.5. Now we're going to do the second 10 of that answer. And we get 70.7 or 71 degrees. So this turns into an answer of the resulting velocity would be 11 meters per second at 71 degrees, and we said north of west. All right, so now what we are going to do here is we are going to do D, which it says, how long does it take to reach the other side? Well, it says that the river is 100 meters wide. So D equals 100 meters. Um, the velocity that it is traveling in that direction, okay? So we imagine here that the river, right, is going in this direction. The river flow is westerly, because that's what it says here. But the canoe is moving north. So it is that northern component that is going to determine how long it takes the boat to get to the other side. So, right, this is the northern component. They're traveling at 10 meters per second. The river is taking them 3.5 meters per second, and they're kind of resulting in this direction here. So they've got 10 meters to travel. The question is asking us for how long, and now we only care about the velocity in that direction, which happens to be 10 meters per second. Now, I know that's kind of confusing, but it's because we really don't care how far downstream, just in the northern direction, how far you're traveling. So B equals D over T. If I was to rearrange this, right, I get T equals D over V. So this is 100 meters divided by 10 meters per second, and we would find out that it takes 10 seconds. Now, E asks us how far downstream the boat lands when it reaches the other side. Well, we know this whole travel time now is going to be 10 seconds. That's how long it's going to take them to go across the river. So now we are like worried about how far downstream they're going to be pulled. So we know that they are going to be pulled westward at a velocity of 3.5 meters per second. And the question is asking us how far in that westward direction are they going to be going? So V equals D over T. We are trying to figure out D. So D equals V times T. So that is equal to 3.5 meters per second. Okay, and that is west, because that's the direction that the river is flowing, times these 10 seconds that it takes me to cross. And we would do times 10, here we go, 35 meters west of the starting point. 35 meters west of wherever the boat started. All right. So the next question says that a ferry is moving at 20 meters per second north across a river that has a velocity of 6.5 meters per second east. The river is 1,000 meters wide. We need to calculate the resulting velocity, including the angle and direction, how long it takes to get to the other side, and how far downstream the boat lands. So the boat traveling north at 20 meters per second. The river has a velocity east. Let me just put this on the other side here. Of 6.5 meters per second. My resulting is this way. Then we're going to put our coordinates here for theta. So we are going to say it's going to be so much east of north. So in order to figure out the hypotenuse there, we know a squared plus b squared equals c squared. So c is equal to the square root of a squared plus b squared, which is the square root of 20 squared plus 6.5 squared. So the square root of 20 squared plus 6.5 squared. And I get a value of 21.02, or just 21 meters per second. Now we need to figure out at what degree. So again, we're not given hypotenuse, so we're going to be using tan. Theta is equal to my opposite, so 6.5 meters per second all over the adjacent at 20 meters per second. So 6.5 divided by 20 gives me that decimal. I'm going to do my second 10 of that answer. And I get 18 degrees. So this would be 18 degrees east of north. So for A, my answer is going to be 21 meters per second at 18 degrees east of north. Now the question asks me how long it takes to reach the other side. Well, now I'm only concerned with this 20 meters per second, and we know it's 1,000 meters across. So B, we're traveling across at 20 meters per second, so that is the velocity. It's 1,000 meters across. Question asks me for time. V equals d over t. Solving for t equals d divided by v. So 1,000 meters divided by 20 meters per second. So I'm going to get 50 seconds. It doesn't take that long, a little bit less than a minute. C asks me how far downstream. So now we're concerned about the component of our velocity that is representing the river, which is 6.5 meters per second. And it's going to be east. So 6.5 meters per second east, that's my velocity. And we know how long it takes us to travel across now, just 50 seconds. And we need to calculate the displacement that I will be taking on my journey. So velocity is displacement over time. Displacement is velocity times time. So in this case, we've got 6.5 meters per second east multiplied by, sorry, I ran out of room here, 50 seconds. So 50 times 6.5 gives me 325 meters east of where they started. All right, so hopefully we understand all of that, and I will be around tomorrow to answer any questions.